Thank you.
That's it, Ken?
Yes.
Okay, thank you. All right, so you just heard about CSPP Leo from Liam, and now you're going to hear about CSPP Geo, status and plans. Same dog, different leg. Is that right? Okay, who says it's right? I speak a little bit of Australian. I want to, so Liam did a good job. He had some nice things to say at the beginning of his talk. First of all, I'm not going to go through all the names of the people that are working on the project that are on this slide. There's a lot of overlap between Leo and Geo, a very talented group of people that make this all possible. And also I want to reiterate what Liam said. This project is very much a cooperative effort, and we work closely with the ASSIST group at NOAA, with the science teams at NOAA, including Algorithm Working Group, and also with, what was the other group I was going to mention? Other groups at NOAA. So, oh, the PRO team. The PRO team in the ground system, we have a close collaboration with them as well. So we couldn't do it alone. It very much is a cooperative effort. So I'm going to start with a brief project overview, talk a little bit about our users, and then go through the different software packages, focusing on current capabilities and then what's coming up. And finally, I'll talk about the Geosphere website and cloud demonstration. So getting into the origin of CSPP Geo, it was before the launch of GOES 16. There was a plan to have a direct broadcast stream, and it was recognized that users would need a way to process that data, to ingest the raw data that they received on antennas and generate higher level products. And so CSPP Geo was born, and it's been located at the University of Wisconsin ever since. We modeled it after the CSPP Leo project. We started with an ingester package that we kind of rapidly prototyped before the launch of GOES 16 to get that out to users to help them to build their systems, anticipating the GOES-R series. And then later we added higher level, level 2, and imagery products. And most of that is based on science algorithms that were developed under Algorithm Working Group. Supported missions include GOES 16, 17, and 18, and I'll be talking a fair amount about GOES 18, Himawari 8, as well as legacy GOES 13 and 15. And we've also added, or we're adding support for GK2A and FY4A. And most of our funding comes from the NOAA GOES-R program office. We're very grateful for that funding. So, you know, the software and support model is very similar to CSPP Leo. Liam talked about this a little bit. The software is released as self-contained binary packages built for Linux, so users don't need to install any third-party software. They don't need to compile anything. When we talk about products, usually we're talking about netcdf files or geotiffs. It doesn't have to be like that. It could get into some more you know, holistic or higher level products that go beyond netcdf files. At this point, I consider it to be kind of a link in the chain, and users can develop their own applications on top of that, and they do. We offer quick looks image generation software that lets users, you know, plot up products and see what's going on, and the software is free to download and use, of course. And users have access to the CSPP team for software support, and generally that includes developers. So Jess is on the front line there, and as well as Kathy, but often the developers will weigh in to answer some of the more in-depth questions. So some unique capabilities and also challenges exist with Geo as compared to Leo. The first is that the data stream is always on, so you know, you have to, you need more hardware, and you have to be always processing in order to stay, to keep up with the data stream. The advantage is, of course, with Geo, you get a much higher temporal refresh. So in order to keep up with the data, parallel processing is needed. With Leo, it's an optimization to decrease the latency, but with Geo, you really need it, or you're going to fall behind. So Liam talked a little about the target platform for LEO. And there was a question from Matt about that. It's a little different for GEO. Currently, the target platform for new releases is CentOS 7, which, as Liam mentions, reaches end of life in 2024. So going forward, all new releases will be built for CentOS 7. We're planning to continue to support on CentOS 7 until end of life. So that's a little different from LEO. And new releases, we've been evaluating Rocky Linux 8. For the most part, it's gone well. We found a few little things, little snags, things that need to be addressed, which I think is fairly typical when you're going from one major software version to the next one. And I guess to back up a little bit, you know, there was kind of a change of course that Red Hat made with CentOS 8, where they discontinued it ahead of schedule, and they're moving to the streaming model, and some users are concerned about that. So that's why we're looking at these alternatives. So Rocky has kind of emerged as a favorite, I think, among the community, the Linux community, I guess, but there are other options. So we're not committing to Rocky Linux 8 at this point, but we're definitely having a good look at it. So dynamic ancillary data that's required for level 2 processing is acquired and staged at the UW. One recent development is that we stood up a secondary offsite ancillary data server. So if the server at Wisconsin goes down, users can obtain data from the other server. So CSPP Geo Software is used at half of all GRB receive stations and probably more. This is around the world. So if you look at the map on the right, I hope you can see it. It's a little smaller. This is the same map that was on Liam's slides for Leo, and Alan showed a similar map. So this was just updated by Jim Davies. I have to thank Jim for doing that. I just mentioned that the map I had was a little out of date, and the next day he turned around this new map. We have 1,115 registrants from 63 countries. And if you look at the graph on the bottom, it shows the red line is the number of registrants over time, and the blue line is the number of countries where users have registered to download. So we've just about doubled the number of registrants since the previous CSPP users meeting. And you can see, you know, both lines are going up at a good clip. Even the number of countries is continuing to increase. Our users include NOAA, NASA, international med agencies, receiving station vendors, data and weather service providers, and the university and research community. So some of the people who are in this room today. And as of 2019, the National Weather Service transitioned to using CSPP Geo Software at the 8 sites that they operate that receive GRB or Himawari cast data. They're running CSPP Geo Software on something like 50 servers. And we have a subcontract to provide 8x5 support with IBSS as the prime. That's separate from our NOAA grant. We provide user briefings at the GRB user group, which Seth Klevenstein talked about earlier today. I highly recommend anyone who operates a GRB antenna or uses GRB data to become a member of that group. That's how you find out about news affecting GRB, and at various meetings and conferences. We provide direct user support by email. We also operate a user forum, so people can ask questions there. We find generally users prefer to email us directly, but that forum is there as a resource, and we also use it to disseminate news and information to users. Okay, so the first software package I want to talk about is the GRB package, and a little background on GRB, which I think has already been covered today, but just to reiterate a little bit, users who are within the footprint of goes east or goes west can receive the data directly via the goes rebroadcast stream. And the way that it works is the data is sent down from the satellite to the ground system, and it's processed through to level 1B, or in the case of GLM to level 2. It's bounced back off the satellite, and a user can receive that. It includes data from all instruments, the Advanced Baseline Imager, the Lightning Mapper, and Space Weather, and it's all at full resolution, all time steps, full spatial and spectral resolution. So then a user who's running the GRB software, the CSPP Geo software locally, can reconstruct the same products that were generated on the ground system with very low latency. And the reason it can be done with such low latency is it's inherent in the design of GRB and the ground system, that as the data is being sent down, it's being acquired, it's being observed and sent down in chunks. It's being processed on the ground system and streamed back to the users. And then if they're running the GRB software, it's being constructed. And by the time the last observation comes in, it just has to be processed, that last chunk, and written out to disk, and they have a complete product. So it's a really nice system. So this is our only software package that actually runs as a server, and it processes the packets and reconstructs the data sets. So basically, if you look at this diagram on the lower right, it's the kind of the key, the package in yellow. It's the key to generating products from GRB. You have to run that first, and then you can run other packages to generate higher level products. So looking at recent software releases, since the last CSPP user group meeting in 2019, I counted 5 releases of the GRB package. This includes 3 releases that were associated with updates to the ground system. So what happens is sometimes when there's an update planned for the ground system that affects GRB, actually whenever there's an update that may affect GRB, we get documentation and test data if we ask for it from the ground system people, and we test that with our software, and if a software patch is needed, we develop that and get that out to users so they can install that on their systems before the change goes live and avoid any impact. And typically these updates affect only a subset of instruments. So like if a user, say it affects the solar ultraviolet imager only, if a user doesn't care about that product, then they don't actually have to install the update. So five releases over 3 years. I think the release cadence is slowing down a little bit. This is for the GRB package, and I think that's a good thing because we understand that there's an impact on users. There's a cost to installing updates and doing all the testing that's required for that. So I want to talk a little bit about GOES 18. Of course, GOES 18 was successfully launched on March 1st, 2022. There's an improved cooling system and an improved magnetometer design. It's now been drifted to a position very close to GOES 17, near GOES West. And as I think Seth mentioned, it's scheduled to replace GOES 17 as operational GOES West on an accelerated schedule. This is, of course, because of the cooling issues that affect GOES 17 ABI. But before it goes operational, as an interim solution, something called interleaving is planned. And this is a single GRB stream with data from multiple satellites. In this case, it's GOES 18 ABI along with GOES 17 data from the other instruments. And the plan is that interleaving will be in effect during the times of year when the GOES 17 heating is a problem. And in the remainder of 2018, or the remainder of 2022, there are, I believe, two heating periods. So during those times, users will see the interleave data if they're receiving GOES West. The first one starts on August 1st. But the data will continue to be relayed by GOES 17. So they've had multiple post-launch tests of this interleaving, and the good news is that it worked. The CSPP Geo team participated in those tests. We were actually in a Microsoft Teams meeting with the pro team, with the ground system people, and telling them in real time what we were seeing. And we didn't see any problems of note in the data stream, and we were testing CSPP Geo Software, and it worked well. So what we can say is that for users who are currently processing the GOES West stream using the current version of the GRB package, which is 1.0.26, no software or configuration updates will be needed to process interleave data or to process GOES 18. So, if you were running the software during the interleave test, you would have seen GOES 18 products appearing on your system. And that's GOES 18 ABI, I should say. And that's exactly what will happen during these interleave periods. Then looking forward to when GOES 18 becomes the operational GOES West satellite, which is scheduled for January of 2023. If you're running the current version of GRB, you will need a configuration change because the software actually cares about what satellite the stream is relayed by. However, we are planning to release a software update in late summer, early fall that will allow processing of data from any GOES-R satellite without making a configuration change. So you can install that before the changeover, and then you won't have to do anything in sync with the changeover. So I know that's a lot of information, but we're going to post a message to our user forum that'll contain the information about the CSPP Geo Software, or you can always contact us if you have any questions. But the good news is, basically, the takeaway should be you don't need to do anything. So now that we have GOES-18 in orbit, we can produce images like this. These are quick looks that were generated with the GRB package. 3 ABI imagers from geostationary orbit. And in the middle is GOES-18. This is taken from the interleaving test. And the images are all at the same time. On the left is GOES-17. At this scale anyway, you can't see any differences between those 2 images. They're right next to each other. They're also reprojected to the same projection. So it's a good thing that you can't see any differences. I want to talk a little about product latencies. I know it's a big topic for this meeting, mainly on the LEO side. But this is an example of the kinds of latencies we're seeing on our antenna, our GRB antenna, right here in Madison. The latencies are shown in seconds, and they're measured from the time of the last observation to when the product is complete and the file is sitting on the user's disk. And you can see that latencies are below 10 seconds for all products other than SUBI, which is pretty amazing. So I mean, this is because of, as I mentioned, the way that the GRB stream is designed. And actually, these latencies are better than they would have been a couple of years ago. We did release a software update, I don't know, a year and a half ago, that eliminated a wait period that we had added in to compensate for an issue in the GRB data stream. So these are, I think, latencies that the LEO people can only dream of. Is that accurate? I don't know. We'll hear more from Bruce Flynn. You can compare the numbers. Let's just say they'd have to work very hard to get latencies like this. All right, enough on that. Moving on to the AIT Framework Level 2 software package, its job is to further process ABI data to generate Level 2 geophysical products. It uses research versions of the GOES-R product algorithms that were developed by Algorithm Working Group. The core software that it relies on was developed and is maintained by the ASSIST group at NOAA. We get science updates. The process is kind of the same as what Liam outlined. The science updates come from the science teams to ASSIST, and then to us, and also to the ground system. And Mike Butler is going to talk more about the collaboration with ASSIST in the next talk. I also want to mention, so we do sometimes production releases and beta releases. Production releases we try to do them in sync with the same capabilities being integrated to the ground system. But we may do beta releases before we do the production release that contain capabilities that are not yet in the ground system, and so users should understand that those are preliminary and non-operational. The current production release is version 1.0. It generates a subset of the baseline products that are shown on the right. We did have a patch last July to address an issue that was triggered by an update to the ground system. It was a change that we were notified of, but we didn't pick up on that it would affect the Level 2 software, so we had to get an emergency patch out. So we also released, so moving on now to version 2, we released an initial beta in January of 2022. It added the capabilities that are shown in the chart on the right in yellow. There were 2 new products. Those are winds and fog. And we added GOES-17 support for a subset of the products, and there was a transition from the baseline to the enterprise algorithms, which is the first major science upgrade since the initial algorithm versions. And there were some changes under the hood as well. We've gotten a lot of feedback on this beta, which really helps us a lot. Users sometimes find issues, And just to hear what their priorities are helps us to know what we should be working on. So if you have any feedback, we highly encourage you to let us know. And since that beta release, we've done a lot of performance testing. We found that the full set of version 2 products could be generated on the machine that was recommended for the version 1, the earlier release, which was kind of surprising with the new products, but it's a good thing. So this is all products, all time steps. This also includes high resolution wins, the channel 2 wins, which is a real CPU hog. We had disabled that by default in the beta release because we hadn't fully tested it yet, but we're happy to say you can run it on that version 1 spec machine. However, it's very, very close to the wire. There's not a lot of margin there, and the bottleneck is disk utilization. So we have a mitigation that we have put in place and we recommend users do as well, and that is to use RAM disk. So what that does is your products are being written out to disk, and then you can copy your both intermediate and final products. You can copy the final products then to disk. And there should be plenty of RAM in that system that was spec'd out for version 1. And there was one other recommendation, which is to run wins as a separate job, and that's because the wins takes a long time to generate the products. And so if they're all in the same invocation, then you'd have adverse latency impacts on the other products. So you just run them as separate jobs. And the graphs on the right, I know you probably can't read the, this is a Grafana graph showing system resource utilization. The top is CPU usage, and you can see there's kind of a wavy pattern. It's a week of data, so there's kind of a diurnal cycle. Otherwise, it's very stable over time. Upcoming releases of the framework, we're working towards a 2.1 beta release in mid-July. And that's timed to be before the interleaving begins. It'll add preliminary support for GOES 18. We also got a delivery recently from Assist, and that includes some science updates that'll be included there, and some other changes coming out of beta tester feedback, as well as quick look improvements. So look for that in mid-July. We're going to be working really hard to get that out. Then the production release is currently planned in sync with the same capabilities going into the ground system, which is currently scheduled for February of 2023. Then looking forward even further, we're starting work on a version 3, so a new major version of the AIT framework, and that will add some products which are shown in the table on the bottom. Those are the sounding products as well as rainfall rate and cloud cover layers. And we're planning an initial beta in June of 2023. Moving on to the GRB Software Package, which generates high-quality imagery and animations from GOES 16 and GOES 17 ABI and AHI data. You can see some true color examples on the right. It also generates some other composite RGBs as well as single-band imagery. Output is in GeoTIFF format, and it also lets users remap to different projections. This has been a very popular software package. The current version is 1.0.2. You can download that from our website, and we're working towards a 1.1 that's planned for release this summer. And that will add, for the first time, some ABI level 2 products. We selected cloud top height and cloud top temperature. We hope to expand to other level 2 products in the future. It'll include gridded GLM. I'm going to talk a little bit about that in a minute. And overlays, so you can overlay images. We're also adding support for GOES 18 provisionally, as well as GK2A AMI and FY4 Agri. So Dave Hayes is the main developer. He's cut a couple of betas, and he would be happy to share that with anybody who wants to be a beta tester. So just drop us a line, and we'll send that your way. And you can see that now on the right, this is the full set of imagers that will be supported. And this is an example of the level 2 products that I mentioned, cloud top height and cloud top temperature for the same time step from GOES 16. So I just loaded them up in Google Earth. So they're GeoTef. They've got the navigation information included, so you can load them up in a GIS type of application. So this is just a really pretty example of a true color image that was created with GeoTef, with GeoGrid by Tim Schmidt. And it shows the moon rising or setting, I don't know which, over the Earth, and it's really amazing. The reason we don't see this very often is because Tim Schmidt has access to data that the rest of us don't have access to. So typically in the space region, the pixels are trimmed, so this would be black. But he had someone go back to the level 0 data to produce this image. Moving on to the gridded GLM software package. It's based on underlying software that was developed by Eric Bruning at Texas Tech and is being operationalized by Scott Rudlowski. It generates a new set of GLM products that are on the ABI grid, and they're aggregated at 1-minute intervals. Those are minimum flash area, flash extent density, and total optical energy. The National Weather Service has been working with these for a while now. It recovers spatial extent information that's not available in the level 2 data that's distributed over GRB. And it has the ability to create AWIPS compatible tiles. There's an example of the data loaded in AWIPS on the right. Our initial beta was released in March of last year, and we're working towards a version 1 production release, which will add GOES 18 support, parallel processing for reduced latency, and some other changes. And we're going to then, as we get updates from the science team, we'll get those out to users. Nick Beerson has a poster on this, so I would encourage you, if you have any interest or questions, to talk to him. So this is an example of an image that was created by Dave Hayes using GeoGrid. It's an ABI GOES 16 true color and then gridded GLM overlaid on top. And this is a storm that passed through Wisconsin last week. It produced multiple tornadoes in Wisconsin and some damaging straight line winds. And just to show you how easy it was to create, it was just 3 commands. So to create the 2 GeoTIFFs and then overlay them. This is an example of something you'll be able to do with the new version of GeoGrid. Moving on, we have a level 2 package for Himawari AHI called GEOCAT. It's based on software that was developed by Mike Pavlonis for his own work, and it uses algorithm software that was algorithms that were developed for GOES-R but have been adapted for AHI. And we released a beta back in fall of 2016. We haven't done a lot of development since then, but the new thing is that JMA has announced plans to switch from Himawari 8 to Himawari 9 as the operational satellite in December of this year. So we've started talking about, and we're planning to work towards a release that will support Himawari 9 to come out in late 2022. As Liam said, I may run over a bit. Okay, I'll try to rush things. We have a package called AXI Tools, which is a set of utilities for ABI and AHI, basically data formatting mainly. It produces tiles that are compatible with AWIPS. This is being used by the National Weather Service. And the news I wanted to mention is that we're working on updates for GOES 18, both GOES 18 and Himawari 9 support, planning to release a patch in July for GOES 18 AWIPS compatibility, and another release in fall for Himawari 9. And I think this is the last software package I'm mentioning. ABI Flood Mapping is based on software that was developed by Sanmei Lee at George Mason University. There's already a Leo package for VIIRS flood mapping. Of course, the advantage with VIIRS is you get higher spatial resolution. With ABI, you get the higher temporal resolution, and then you can, by compositing images over time, you can get a clearer view of the surface. So we released an initial beta version. We haven't released an initial beta version yet. We're planning to release it in summer of 2022, and then we're hoping to add GOES 18 support sometime in 2023. And then I think this is really my last slide of substance. I wanted to mention the Geosphere website and cloud computing demonstration. This was done under internal SSCC funding. We containerized CSPP Geo Software, so it's running off of GRB data that's acquired on our roof. And it's running on cloud equivalent infrastructure that we've developed locally. We've also tested it in both Google and Amazon clouds. At the end of it is a website called Geosphere. The URL is shown there. You can go to it and check it out. It's kind of a Google Maps type of interface where you can scroll and pan and zoom in and zoom out, and the tiles are loaded up as needed. So currently it supports GOES 16. We're planning to add, or we're in process of adding GOES 17 and 18, and also adding some RGB images and the ability to save off images and videos, which has been kind of widely requested. Dave Hayes is going to be giving a related talk tomorrow, so I would encourage you to check that out. It should be a good talk. This animation on the right this is GOES 18 that was taken during the interview test, and I think Liam actually saved this one off. So that was my last slide. I just want to leave you with this list of CSPP Geo team members. The names in purple are the people who are at the meeting. So I'd encourage you, if you have any questions, track them down, talk to them, tell them how you're using their software. I think they'd really love to hear that. Thank you.
Thank you. Are there any questions for Graeme?
About when you said that AIT was version 1 was perfectly compatible with the hardware requirements, no? Version 2 beta 4. And I just want to tell you that we have to use a different server because it wasn't working in the other server.
Yeah, and that doesn't surprise me. You know, I mentioned the RAM disk optimization. We were getting like dropped products until we did that. So we're going to document that. We're working towards this next beta release, which will come out in July. So we're going to document how we use RAM disk, and you can try doing that.